Hello, everyone. Okay, so we're just going over now the solutions to the practice problems in your booklet. So, converting to polar form. Convert the following complex numbers to polar form. So, let me just split this page up to make it a bit easier for myself. So, first one here. Well, let's calculate my radius. Not my radius, sorry. Oh my god, my radius. I'm crazy. My modulus. My modulus is going to be 1 plus minus 4 squared, which is just going to be equal to root 17. Ugh, not nice. Anyway, root 17. My reference angle is when I plot this out. So 1 minus, so it's in my fourth quadrant here. So tan inverse is equal to the positive of b over a minus 4 over 1. My reference angle is going to be equal to tan inverse of 4. My reference angle is going to be 1.33 radians. And then I'm in the fourth quadrant, so my argument is going to be equal to 2 pi minus 1.33. And that is equal to, minus, not minus, sorry, that's going to be equal to 4.96 radians. 4.96 radians. So then to convert to polar form, let's just sub it in. Bing. Bong. So I split the page more. So polar form is going to be equal to root 17 cosine 4.96 plus I sine 4.96. And that is my final answer there. Let's look at the next one. Minus 2 minus 2i. My modulus is going to be equal to, so minus 2 squared plus minus 2 squared, which is going to be equal to root 8, which is equal to 2 root 2. My reference angle is going to be equal to, so this is going to be minus is going to be in this quadrant here. That is going to be equal to tan inverse b over a, so it's 2 over 2, which is going to be equal to tan inverse 1, which is a quarter pi. My reference angle is, it's in the fourth quadrant, so remember it's pi plus my reference angle. So that is going to be equal to 5 pi over 4. In polar form, this is equal to 2 root 2 cosine 5 pi over 4 plus I sine 5 pi over 4. So this one here, minus 2 plus 3i. So my modulus is equal to, so minus 2 squared plus 3 squared, which is going to be equal to 4, 9 is root 13. My reference angle, so minus 2 plus 3i, so it's in my second quadrant because I have a negative x, negative on the x-axis, positive on the y-axis. My argument is going to be equal to tan inverse the positive sense of 3 over minus 2, so it's just going to be 3 over 2. Tan inverse 1.5, which is equal to 0.983. I'm in the second quadrant, so my argument is equal to pi minus 0.983. And I get here my argument is equal to 2.17. radians. Therefore, my in polar form is equal to root 13 cosine 2.16 plus I sine 2.16. Then the last one here, 3 minus 3i. 3 minus 3i. So 3 squared plus minus 3 squared is equal to root 18, which is equal to 3 root 2. I'm going to put on your calculator. My reference angle is equal to, so it is 3 minus 3i. Yeah. So 3 minus 3i is in quadrant 2. So that's going to be equal to tan inverse of the positive of minus 3 over 3. So that'll just be 3 over 3, which is just 1. So it's going to be a quarter pi. My reference angle then, I'm in the fourth quadrant, so it's 2 pi minus a quarter pi, which is equal to 7 pi over 4. Therefore, my polar form is equal to 3 root 2 times cosine 7 pi over 4 plus I sine 7 pi over 4. And there are my solutions for that question. Next question is very straightforward. Convert the following numbers into rectangular form. So all we need to do is we need to evaluate it with our calculator. But the problem is you cannot just put all of this in your calculator because we have this pesky little I down here. So we need to evaluate my trig parts separately. So I have 3 times cosine 3 pi over 2 is going to give me 0. Plus I sine pi over 2, which is going to be equal to minus 1. I'm going to have 3 times 0, which is just 0. 3 times minus I is just minus 3i. There is my solution for the first one. The second one is just going to be root 21 times cosine pi over 2 is 0. Cosine, let's say plus I sine pi over 2, which is just going to be I times 1. So my answer here is going to be 0 plus root 21i. And then finally the last one here is going to be 3 times cosine 7 pi over 6 is going to give me minus root 3 over 2 plus I sine 7 pi over 6. 7 pi over 6 is minus 3 over 2. Multiply this in, I get minus 3 root 3 over 2. And then this is going to be minus, sorry, not minus 3 over 2, this is going to be minus a half. I do apologize, I got to have myself. 3 times minus a half is minus 3 over 2i. And that is my final answer there. Right, so there are just the solutions to the practice problems. Let's look at exam questions. So polar form always comes up. You need polar form, especially when we do De Moivre's theorem later on in the chapter. So this is from 2019. Given the complex number v is equal to 2 minus 2 root 3i, write v in polar form as or times cosine theta plus I sine theta. So easy peasy, lemon squeezy. So find my modulus first, which is equal to 2 squared plus minus 2 root 3 squared, which is equal to 4 plus, this is going to be equal to 12, root 16, which is equal to 4. So my modulus is equal to 4. Oh, happy days. Now let's get my argument. So here's just a little plane I drew to sketch. So 2 minus 2 root 3i. So I'm in quadrant 4. So my reference angle is going to be equal to tan inverse. So the positive sense of minus 2 root 3 over 2, which will equal to, so it'll be minus 2 root 3 over 2. Take the positive of that, tan inverse of minus root 3, which is just positive root 3 when you find the absolute value. And my reference angle is tan inverse root 3, which is equal to 1/3 pi. 1/3 pi, and then I'm in the fourth quadrant, so it's 2 pi minus 1/3 pi. theta is equal to 5 pi over 3. So my final answer is going to be equal to 4 times cosine 5 pi over 3 plus I sine 5 pi over 3. That's my final answer there. Right, let's look at this last one here. This is a complex number. Verify that z can be written as 1 minus root 3i. So 4 over 1 plus 3i, we need to verify it can be written as 1 minus root 3i. So this is a division. So I'm doing division, so I'm multiplying the top and the bottom by the conjugate. So multiply the top by 1 minus root 3i. Multiply the bottom by 1 minus root 3i. That is going to be equal to 4 minus 4 root 3i. And the bottom, when you multiply it out, will end up equaling 4. Right? So multiply it for yourself, but the bottom is going to equal 4. Divide 4 in, I have 1 minus root 3i. And I've just proven that. Then we need to plot this on an Argand diagram and write it in polar form. So let's write it in polar form. You get my modulus. So it's 1 squared plus root 3 squared, which is equal to root 10. Root 10, let's calculate my argument. So I am 1 minus root 3i. So I'm 1 on the x-axis down here. So I'm in the fourth quadrant. So theta is going to be equal to tan inverse the absolute value of minus root 3 over 1. Theta is equal to tan inverse positive root 3. Just taking the absolute value here. Theta is just going to be equal to, again, 1/3 pi. And I'm in the fourth quadrant, so my argument is going to be 2 pi minus my reference angle, which is equal to minus 5 pi. Oh, not minus 5 pi over 3, just 5 pi over 3. Therefore, as in polar form, my answer is going to be root 10 times cosine 5 pi over 3 plus I sine 5 pi over 3. Right, and they were the exam questions and all for polar form. So don't worry, you're going to be doing a lot of polar form throughout this chapter. And I hope the video was some help to you guys. And I'll catch you guys later. Bye.